So this video is on chapter 4 MA, homework number 15, modeling worksheet number 2. So extraterrestrial being problem. Researchers find a creature from an alien planet. Its body temperature is varying sinusoidally with time. 35 minutes after they start timing, it reaches a high of 120 feet. 20 minutes after that, it reaches its next low at 104 degrees Fahrenheit. So we're going to sketch a graph of the sinusoid, write an equation, and then we're going to answer these questions. So looking at this, some of the important information that we have. Okay, 35 minutes after the start of time, it reaches a height of 120. 20 minutes after that, it reaches its low of 104, which means this is going to be at 55 minutes. Okay, so to start sketching this, okay, this is going to be temp and minutes. Yeah, minutes. And temp. And the high is 120 degrees. The low is going to be 104. And we need to figure out the middle. So to figure out the middle, what we're going to do is we are going to average 120 plus 104 divided by 2, and we get 112. So our vertical shift is 112. Okay. So now let me just kind of draw in, here's my vertical shift. That's going to be my zeros. Here's my high at 120 and my low at 104. Draw that one better. And then we know that 35 minutes after the start, it reaches a high of 120. So I'm going to put 35 here, and that is going to be a high of 120. And so I've got 1, 2, 3, 4, 5. Let me just plot my graph, and then I'll put my values. Okay. We know that 20 minutes after that, it reaches the low. And so that was 55 minutes. And so since this is 20, from here to here is 20. That means from here to here is going to be 20. So that's going to put us at 75. And halfway between those would be 10 and 10. So that's going to be 45 and 65. Okay, so that's our graph. Now our equation. We're going to have y equal, I'm going to do a cosine graph. My amplitude is from here to here. So my A is going to be 8. I'm just going to be a positive 8. And then cosine, and then my b, 2 pi over b is equal to our period, and our period is going to be 40 minutes. So I'm going to get 2 pi over 40, which I can reduce to pi over 20. So this is going to be a pi over 20. I am going to start this at 35, so this is going to be an x minus 35. And then my vertical shift was 112. So that's going to be our equation. So then we're going to take this equation, and they want us to figure out what was the temperature when they started timing. Okay, so we want to know what was it at 0. So I'm going to put this into my calculator. And actually, I'm going to put it on my y equal. I'm going to make sure my calculator is in radians. I'm going to do 8 cosine pi, oops, hold on, sorry, 8 cosine pi over 20 times the quantity, x minus 35, and then plus 112. And I'm just going to zoom in a little bit more. Okay. And so I'm going to go to the window and I'm going to adjust it so that it looks like my graph. So I'm going to go -5. So I'm on the other side of this to 75. Maybe I'll go slightly beyond that. So I'll go to 80. And let's say I just scale it by 5s. And my load is going to be 104. So let's say 100 is my minimum. And my maximum, let's go to 125. I just want to go above where I need to be. And we can just scale this by 1s, is okay. Or here, I'll do it by 2s. I'll do it by 5s. We'll just keep everything in 5s. Okay, so I'm going to hit graph. And there's our graph. Okay, and they want us to figure out the temperature when they first started the timing. So one way you can do this, we want to know when it was equal to 0. So I can do second and the trace button for the word calculate. I can go to number 1 and I can type in any X value that I can see on my graph. Okay, so if I want 0, I need to make sure 0 is in my window. I'm going to put 0 in. I'm going to hit enter. And it's going to tell me what that answer is. So 117.65685. So let's say 117 point, let's say 66 degrees is my answer. Now on the next part, find the first 3 times after they started timing at which the temperature is 114. So I'm going to go back to my calculator. I'm going to go back to my y equal. I'm going to put in 114, y equal 114. So I get that line drawn in. Okay, so that's 114. And I want the first 3 times. So 1, 2, 3, 4. If I can find this one and then this one, I know that this one is going to be the period, which is 40 away. So I can just add 40 to it, okay? So what I'm gonna do is I wanna find the point of intersection of this line with the sine curve. So again, I'm gonna hit second and the trace button for calculate. I'm gonna go down to number 5. I'm gonna arrow down. You just press 5 if this is the one you want, intersect. And I'm gonna drop down to this by hitting the down or up arrow. That would get me onto a line, and I'm going to come to the first point of intersection. I'm going to hit enter for the first curve, enter for the second curve, guess. I hit a 3rd time, and then it gives me 3.39. So 3.39 minutes. Okay, so now I want to find this one. So I'm going to do the same thing. Second calc, go to intersect again. And this time, I'm gonna arrow up to my line, arrow up or down. If I'm on my curve, it's fine, but I got to go back and I got to go down and up. If I'm on my line, I can just go straight across. So I want this one. I'm gonna hit enter, 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 and I get 26.61 minutes. Now this next one, see, this was coming down. This is coming down. So this is going to be 40 away. Okay. So I am going to take 339 plus 40, and I'm going to get 43:39 minutes as my 3rd one. And just to show you, I'm going to go to intersect again. I'm going to come over here, hit enter, enter, enter. And you see, I did get my 43.39. If I needed my fourth one, I would take this one, which was 26.61, and add 40 onto that to get the same spot over here. Okay, so that's that problem. Now this next one, Tarzan. Okay, so on this, Tarzan is swinging back and forth on his grapevine. As he swings, he goes back and forth across the riverbank. When alternating over land and water, Jane decides to model mathematically his motion and starts her stopwatch. Let T be the number of seconds the stopwatch reads, and let Y be the number of meters Tarzan is from the riverbank. Okay, assume that Y varies sinusoidally with T, and that Y is positive when Tarzan is over the water, and negative when he is over land. Okay, positive when he's over the water, and negative when he's over land. And again, it's representing the number of meters he is from the riverbank. Positive means he's that distance across in the water, and the other one, positive, would be over land. He's that far from the riverbank. Jane finds that when T is 2, Tarzan is at one end of his swing, where Y is -23. She then finds that when T is 5, he reaches the other end of his swing, which is 17. So my low is going to be -23, my high is going to be 17. Okay, so let's see. Okay, so -23. Okay, so this is, what was it? It was Y is over water, negative when he's over land. Let's see, sorry. Let T be the number of seconds from the stopwatch. Y is the number of meters. Sorry, I was trying to figure out what units. So this is meters. And T is time. Okay. And did they say what time that is? Seconds. T is seconds. Okay, so his low is going to be -23. His high is going to be 17. And to figure out halfway in between, I am going to average 17 and a -23 divided by 2, and I end up with a -3. Okay, and so this is going to be -3 is going to be my center. So this is my vertical shift. This is the high. This is the low. Okay. We know that at 2 seconds, he is at -23. Okay, so at 2 seconds, I'm just going to put 2 here. 2 seconds, he's at -23. So 1, 2, 3, 4, 5. Okay, so he's going to be low again here. He's going to be high here. He's going to be at -3 at -3. Okay, so that's our graph. We know that at 5, he's at 17. So this is going to be 5. So that is going to be 3 from here to here. So that's half of our period. So I'm going to add 3 over to here. And that's going to put it at 8. And then halfway in between, if I average that, 7 divided by 2 is going to be a 3.5. And 8 plus 5, 13 divided by 2 is going to be a 6.5. So that's that. Now we need to figure out our equation. So I'm going to do a cosine. The distance from here to here is 20. It's going to be a negative 20 because we're starting down. I'm going to do it as a cosine. It was 6 going all the way from here to here is 6. So that is going to be our period. And so I'm going to do 2 pi over b is equal to 6. So 2 pi over 6 or pi thirds. Okay, so that's going to be a pi thirds. Just going to move that. I'll move that over here. Okay, so we're going to have a pi thirds. We are starting here, which was at 2. So this is going to be x minus 2 or t minus 2. I'll put t since they had t here. T minus 2. And then my vertical shift is negative 3. So that's our equation. So now we want to predict when, where he's going to be for each of these times, 2.8 seconds, 6.3 seconds, and 15 seconds. So I'm going to put this into my calculator. I'm going to go to the y equal. I'm going to start fresh, clear everything. Okay. And so I'm going to be putting in negative cosine, negative 20 cosine of pi over 3. And I'll get out of that, times x minus 3, sorry, x minus 2, minus 3. And I'm going to go to the window and I'm going to adjust it for this. So for my x's, starting at negative 5 is fine. I like to sometimes start on the other side of the x-axis so I can see where the y is, the y-axis is. But we only need to go to 8. So let's say maybe I go to 10 and I'll go by ones. And my y minimum, negative 23. So let's go maybe to negative 25. So I'm slightly below that. And we'll go up to 17 we have to go up to. So let's just say we go up to 20. And that by ones is okay. Maybe I'll do this by 5s. I'll do that by 5s. And here's our graph. Now, if I want to find each of these values, I can go to second in calc, go to value, and as long as the x I'm looking for is in my screen, I can put it in. So 2.8 is going to be and that is a negative, and you can see it's showing down where it is, negative 16.38. So negative 16.38 meters. Second and trace again. And this time 6.3. And that is going to be at 1.16 meters. Now this one here, 15. I only went out to, I think, 10. So this 15 is not going to be showing. If I was to put it in, just to show you, since it's not on my screen, it's going to say error, okay, invalid. It needs to be in your window. So I'm going to quit out of that. I'm going to go back to my window and let's just put this to 20 now. Go to 20, okay? That way I can be on my 15. Hit my graph again. And now I can put in 15 and see what that is. Need to wait for it to stop going. Okay, so I'm gonna put in 15. And when I put in 15, I get a negative 13. I get a negative 13. So this is a negative 13 meters. Okay, now the next question says, where was Tarzan when Jane started the stopwatch? Okay, so we want to know where he was at 0, basically. Okay, so I'm going to hit second and calc again. I can go to value and just type in a 0. Oops, I put in a 1, 0. And you can see that he was 7 meters. So this answer was 7 meters over land because it was positive. This one was over water because it's negative. This one's over land because it's positive. This one's over water. So hopefully that is helpful to you guys. The more we practice these, the easier they'll become.